Hello everyone, and thank you for joining us today on this webcast for Managing for Success with MLOps. My name is John, and I'm joined by my colleague Alistair. We're both data and analytics consultants at Thorogood, and we're joining you today from Philadelphia. If you have any questions on the content covered, or more broadly about data and analytics, feel free to get in touch via email or LinkedIn. As always with our webcast, we'll kick off with a brief intro to Thorogood. We'll then discuss the benefits MLOps brings to the business, ending with the bulk of the session, which is sharing our thoughts on the different considerations MLOps managers should be aware of. So who are we at Thorogood? We're an independent and specialist business intelligence and analytics company with a focus on data engineering, data science, and data visualization. Our approach is rooted in understanding business goals and using the capabilities of technology to meet these goals, so customers and business objectives are at the forefront of our approach. We're a global company with offices and consultants in Asia, Europe, and the Americas, and we offer a full range of services when it comes to data and analytics. Those include data and technology strategies and roadmaps, end-to-end implementation of cloud solutions, user empowerment, and analytics services. We deliver value in the data engineering, data science, and data visualization space for key enterprise customers, typically within the data-rich CPG, pharmaceuticals, banking, and insurance sectors. Some of those key customers include Unilever, Johnson & Johnson, Liberty Mutual, Morgan Stanley, Mars, and Genry. Some of you may be familiar with this already, but we are running an MLOps webcast series, and today's session is the third and final part of that series. The first installment was held mid-June by my colleagues Emily and Sarah, who shared their thoughts on why organizations should care about MLOps, focusing on its business case and benefits. The second session by Archana and Brendan provided more detail on the different considerations organizations need to make when planning to implement MLOps. I won't go into more detail here, but feel free to watch the recorded sessions, which are available on our website or YouTube. Before reviewing the benefits, it's important to understand what MLOps is and how it has evolved in recent years. If you joined us for the last webcast, you'll remember that machine learning operations, or MLOps, refers to practices for orchestrating the development, deployment, and maintenance of machine learning models in a scalable and standardized way. Until recently, across our customers in the wider industry, the build, test, and deployment of ML models has been conducted on an ad hoc basis, and the ongoing monitoring and maintenance of these models had not been subject to a formal governance process. This approach may suffice when the demand for ML modeling is light, and it is realistic for a data scientist to continuously oversee the models they create without necessarily developing the code base beyond an experimental version. However, in a data intelligent organization, data scientists need to split their time across many modeling exercises, while the sophistication of data and models and the trust placed in these models calls for specialized software engineering input. Over the past 3 years, MLOps principles have begun to emerge, defining an optimal state for production ML. It ensures models are implemented robustly and efficiently in an automated fashion and are monitored over time so that any degradation in performance can be addressed. Operationalized models are scalable, more easily understood and trusted by the business, and enable ongoing experimentation in enterprise tools. This optimizes the cost and ongoing quality of models. Through automation and the introduction of dedicated roles and processes, MLOps brings together the innovation and exploratory nature of the experimentation with the robustness of operationalized systems to empower data scientists to focus on experimentation and building new functionality, among other benefits. Data scientists receive the benefits of operationalization in an MLOps setup and can add additional value as they continue to experiment, such as advanced and automated model monitoring, alerts on model decay, parallelization, to name some of the most important ones. If they're not doing this already, organizations must shift their thinking to embrace operationalization and the benefits it can provide. Speaking of benefits, let's talk about why you should care about MLOps. Essentially, it is necessary to enable organizations to fully recognize the benefits of machine learning at scale. These benefits include increased accuracy, trust, and awareness by building a framework of auditability, monitoring, and responsiveness. The empowerment of data scientists through automation, scalability, and reproducibility of machine learning solutions allow them to focus on higher value activities. the ability to uncover value quicker with a fast feedback loop that is inherent in ML solutions, and the ability to manage costs by leveraging reusable assets and following cloud infrastructure best practices. With more data available now than ever and significant advances in cloud computing and analytics tools, it has become easier for organizations to experiment with machine learning and AI. However, the majority of organizations are not seeing the benefits. A study that MIT Sloan did with BCG found that 71% of respondents felt they understood how AI would change the way their business generates value, but only 11% reported actually seeing significant benefit, meaning that only a few organizations are managing their ML strategy correctly. So why is that number so low? Today we'll be talking about how to successfully manage MLOps within your organization to make sure you are set up to reap the reward from your investment. We're going to discuss 3 key pillars today: people, processes, and tools. In terms of people, we'll address the skills needed and how teams can be structured to deliver on the promise of MLOps. In terms of processes, we'll share some helpful artifacts to produce, which will help guide you in future work in the space. And finally, in terms of tools, we'll consider how tool selection is made. Underpinning these areas, you have your organization's data, internal and external data sources, structured and unstructured data sets with the potential for massive data volumes. Any MLOps initiative should prioritize data quality and ensure that data can be consumed and refreshed in an automated fashion. Let's dive into some data considerations. When it comes to ML, there's a tendency to be model-centric, focusing on activities to improve the package or algorithm in order to get the most accurate prediction value. Andrew Ng of Deep Learning AI recently spoke on the need to become more data-centric and found that improving data quality can actually have a larger impact on the performance than fine-tuning a model. This is what is meant by data is underpinning the rest of the framework, or that data quality is paramount to model quality. It's emphasizing the point that you could have all the other pieces working perfectly and optimized, but if your data is bad, those issues will propagate and you won't be getting the benefits that you should. So what do you need to ask yourself when trying to assess if the data assets in your organization appropriately support your initiatives? Is the data available from a centralized location? When organizations are shaping data lake strategies, is the data available in a data lake or dedicated data marts? Is there a single source of truth? Where are the model outputs being stored? What you don't want is people going to different places to get the same set of data. And for ML specifically, if you're doing batch processing, you need to know where the model outputs are being stored so that they can be used later. Is your team aware of all the data that is available within the organization and where to find it? Are there other data sets that will help improve their model? Does your team understand the implications of using trusted versus unverified sources in their models? As ML models move from experimentation to production, there may be data sets used exclusively for experimentation and are not certified for use by a wider audience. Ensuring that there is a distinction between a trusted and certified data set compared to a sandbox dataset is paramount in ensuring data quality and building trust. Essentially, you need to know what data is being used in a model, and depending on the types of data, like PII, if ethical practices are being followed and making sure data is not being misused. Finally, is your team aware of the other data assets that have already been created? Can you leverage efficiencies and reduce silos between teams by streamlining data wrangling or reusing features? The end goal being to eliminate redundancy so that the same task is not completed by 2 separate teams, or the same feature is not being developed over again. Now that you have a sense of where you stand, here are some suggested approaches and tools to help you set up a robust data platform and achieve your data quality goals. Defining a data lake strategy, possibly one with a sandbox tied to a curated environment where data scientists can get to the data. You should also have a process to productionize these experiments, moving them out of the sandbox layer and making them available to the business. Use available data cataloging tools so end users can easily browse and discover the data sets that exist in your environment. Such tools will help you with data lineage so consumers fully know where data is being sourced and can ensure that the models built consider all necessary information. A feature store, defined as a central and trusted location for all the features your team might want to use while modeling, gives data scientists assurance that they don't need to worry about the quality of the data coming in from the feature store, and gives them the added benefit to experiment faster by not needing to recreate features. And using a lakehouse gives you the power of relational querying on top of data lake architecture. It helps you organize varied data sources, making them easily interoperable with each other. Leveraging these approaches can bring more attention to your data quality and help your team become more data-centric. I will now hand it over to Alistair to talk about the 3 pillars that good data supports, starting with people.
Thanks, John. So now that we've discussed the foundation of this framework, the data, I'll move on to discuss people, processes, and tools. So it's important to recognize that the ML code itself is just a small portion of an industrialized ML system. Other key components require much consideration, including monitoring, serving, infrastructure, configuration, and analysis tools. This screen visually represents the components of an ML system operating at scale. But with that said, the ML code, getting that right is critical, indicated by this diamond here. So while the ML code may be a small component, it is highly important. And many data scientists have experience developing experimental code in a manner that works for a specific use case. But it's important to make sure that organizations are investing in training data scientists or hiring data scientists that are aware of how to make code scalable, efficient, and reproducible. To kind of illustrate this shift in importance, an existing data science team may be comprised of a product owner who oversees the business inputs into a solution, a data engineer who creates the pipeline to ingest and shape the data for consumption, a data scientist who builds and validates typically experimental models, and a UX developer who produces screens, visuals, and reports that illustrate the output of models. The well-defined MLOps team involves an MLOps manager who can identify and guide projects through industrialization, an MLOps architect who can understand the tools that have been used for data science projects and determine the best architecture moving forward with a project at scale. And then, as just discussed on the prior slide, also an MLOps engineer and MLOps data scientists who can tune a data science solution such that it's capable of that kind of scale and reproducibility. So that's a brief overview of the people element of a successful MLOps strategy. So now let's move on to discuss processes. So there are a number of key artifacts that can be considered or created to guide MLOps adoption within an organization. I'm going to list and then explore in further detail a number of these key pieces of documentation that we at Thorogood have created for clients to this end. A questionnaire is a qualitative way for the MLOps manager or technology managers and leads to understand more about data science projects and the pipeline that could use the MLOps service. An ML test score is a rubric to determine the readiness of an ML solution for industrialization in a more perhaps quantifiable way than the questionnaire. Decision trees can help guide on tools to use or consider using, and they take into account factors such as training volumes, libraries, serving methods, parallelization, retraining frequency, etc. A playbook, so this would be a more kind of comprehensive document that contains guidelines for data scientists and MLOps teams. And finally, a reproducibility checklist, and this would kind of help ensure that projects are completed in keeping with standards that make them easy to scale, reproduce, maintain. So I'll delve into each of or some of these kind of pieces of documentation that we recommend in further detail. So on the screen right now is an example snippet of a questionnaire. Questions and answers in this questionnaire are longer form and tend to describe more qualitative aspects of projects, touching on a variety of aspects such as the business value and purpose of that data science solution, the development standards that we used or are planning to be used, thinking around model governance and refactoring. So this is a questionnaire that would be completed by teams associated with a specific data science project, and then the outputs would be consumed by the MLOps leads and managers who are marshalling the MLOps pipeline. Another kind of questionnaire-like approach for assessing project readiness and suitability for MLOps is the ML test score, which was created by a group working at Google and provides a set of 28 actionable tests that provide a view of how kind of ready or apt for production an ML system is. The below illustration is from their paper, and you can find that online by Googling the name of it. And it kind of illustrates and highlights how much more complex, on the right-hand side there, a production ML system is than something manual. And there's a lot less that you're able to specify in advance with a kind of a more production-ready ML system. The ML test score is broken into several categories, including data tests, model tests, ML infrastructure tests, and monitoring. And then the lowest aggregate score from any of these sections is used to score the project readiness. So essentially, the area in which it's weakest determines how ready it is for production, which is an interesting way of scoring. Another important aspect of an MLOps framework to consider are the tools used. And part of a kind of recommended document that we'd propose creating is a decision tree. So decision trees provide a simple guide of which tools to use along various decision points for data scientists and ML engineers. The decision on which tool to use can be taken anywhere in the ML project lifecycle, but often it's most impactful and important to consider the best tool for the use case when starting out or experimenting. This may necessitate the data scientists think more broadly than the immediate task at hand, but consider how the model may need to scale over time to incorporate other geographies, other functions, other products. Another obvious decision point for switching to a different tool or service or maintaining the use of the current service is during the initial industrialization. However, you're not precluded from switching to another ML service at any point in the future. When deciding on which tool or tools to use, it's important to consider the various aspects of an ML initiative, so training and evaluation, orchestration, deployment, and tracking. Finally, another key and substantial artifact to consider producing when embarking on an MLOps journey is a playbook. This should provide an overview of MLOps and the basics that the staff will need to know. Detailed information on environments that you're using, how to provision resources in those environments, how to engage with the MLOps team, and move a project through that kind of pipeline into an active engagement and then production. How to evaluate a project and its readiness. So that's a topic that we just discussed earlier with the questionnaire. Also introduce the ML test score and other quantifiable methods of evaluating projects. Indicate who the key people involved with MLOps within the organization are, and how to engage those teams. What tools should be used and considered for various different reasons, and then other general recommendations and guidelines to be aware of. So kind of best practices, as it were. So finally, I'll kind of round out this MLOps framework discussion by talking about tools. And I'll start with a very simple view of the technology landscape in the data science and machine learning space via this Gartner Magic Quadrant from March 2021. There are a lot of platforms to consider at various stages of maturity, and from vendors large and established and younger and smaller. Each have their own strengths and weaknesses, and it's important to consider various options for adoption for different use cases. So many organizations will have several of these tools in play simultaneously. And again, some of the kind of artifacts that I just discussed will help guide the decision on which platform, which tool to use when. So what should you consider when selecting data science platforms for use within your organization? Well, first, it's important to consider the infrastructure or cloud that will be hosting your data and the data engineering and data science tools you'll be using. You may consider using your own on-premises servers, for example, or the Microsoft Azure or AWS or other clouds. In terms of this kind of infrastructure or cloud hosting consideration, you should consider where your data currently resides or where it's most readily or easily available. You should consider if that cloud offers the data science platform you're interested in. So for example, something like Azure Machine Learning may only be available on Microsoft's Azure cloud, but an independent offering like Databricks is available across Azure, AWS, and now GCP. Finally, there may be kind of commercial or strategic business reasons for you to consider a certain option, a certain cloud perhaps. Maybe you're actively pursuing a multi-cloud strategy, which is another hot topic and a topic that Thorogood recently produced a video on that's available on our website or our YouTube channel. Or maybe there's a vendor that's offering a certain incentive to move workloads to their cloud, so that there might be commercial reasons to consider a cloud or a certain option there. In terms of the data science platform itself, so the kind of core of the ML solution, there are a great deal of factors to consider. So there's a kind of a long form list here, but there are many, I'm sure, considerations beyond what's been listed. But some of the kind of thinking needs to be shaped around the availability of packages, how pre-provisioned the platform is or how much setup is required, language compatibility, or Python, Scala, what languages you want to use, how GUI oriented it is, so how almost user-friendly, drag, drop, click oriented it is, the degree of specification and control, so are you able to control everything that you want to, the support and user community, is there a big community of people that you could potentially hire or tap into as you kind of adopt and use that tool more broadly, the cost efficiency of that service. So how much does it cost to run? I mean, another kind of commercial consideration there as above. The native data engineering available. So how, can you integrate the data engineering, feature engineering that you need to do with the machine learning, AutoML capability, and then integration with tracking and serving tools. And finally, I'd note that it's important to recognize that tool adoption does not end with tool selection. Instead, it's important to ensure that tools chosen are being well leveraged and that training or support is available to your user community. So that kind of concludes the overview of our MLOps framework. But before we go today, we'll leave you with some parting thoughts on how to get started. So at Thorogood, we have experience in strategizing and implementing MLOps frameworks at the organizational level, enterprise organizations, in fact. From a more assessment level perspective, it's really important to understand where your organization and all of its ML applications and experiments currently stand from a maturity perspective. Having a baseline of where things stand is hugely important to start, and then gaining this understanding, you'll be able to take subsequent steps to kind of strategize and implement some of the more technical aspects that we've discussed and create some of the artifacts that we'd outlined. If you're interested in learning more as to how Thorogood can help implement an MLOps framework, please feel free to reach out. John and I will be happy to discuss that with you. As John also mentioned towards the top of today's webinar, this is the final live webinar in a 3-part series on MLOps, but you should be able to find part 1 on the business case for MLOps and part 2 on implementing MLOps via our YouTube page. We have a lot of data science and ML related content available on demand via our website. So if you enter go.thorogood.com/MLOps into a browser window, you should be redirected to the blog posts, white papers, videos, pre-recorded webinars that we have available. As ever, please feel free to reach out with questions or if you're interested in discussing anything that we've mentioned today further. And thank you for your time.